Today we are going to discuss on a topic called as neural networks. Neural networks is a set of computer algorithms which mimics the human brain, or they work as our human brain. We know our human brain works on neurons. Okay, we have different neurons, and the input signals pass from each neuron to another neuron. Processing happens in each neuron, and the entire result of this processing will help you in making a decision in some scenarios, right? Likewise, in some computer algorithms also we use some neurons, and processing happens within the neurons, and it helps us to make a decision. Okay, so those set of computer algorithms which make use of neurons is known as neural networks. So here we have some interconnected nodes which are known as neurons, and different neurons are connected to each other using a link. Okay, and they learn different patterns from your data, and based on that we make some decision. Okay, it is used for classification, regression tasks, etc. So this is a figure. This shows how human brain looks like. Okay, we have dendrites, axon. The information will pass through, and it gives you the output or helps in making a decision. So this is how a neural network will look like. Here also we have some inputs and some processing happens. If the information is passed and the processing happens, and you get the output. Okay. So we'll look into detail in the further slides. So basically a neural network has these components. It has some neurons. Neurons means they are the processing units in a neural network. Okay. Each node in the neural network is known as neurons, and it receives some input signals also. Now different, there can be more than one neuron in the neural network, and they are connected using a link, and each link is associated with some weights. Okay, they have some weights. Again, this weight means they are the parameters introduced to uh, help the model learn complex patterns. Okay, and we have some propagation function. That means they are the mechanisms that helps to transfer, process, and transfer the outputs across the layers. And learning rule, it is a method by which we adjust the weight of the neural network. Okay, weight and bias of the neural network. So that we'll look into detail in the further slides. So basically, learning in a neural network happens in three stages. One is input computation, that means give the input or we supply the inputs to the neurons, and output generation means based on the parameters, after processing, an output will be generated out of the neuron. Again, iterative refine means if the predicted output is not correct means then we will adjust the weights and biases, values of weights and biases, and again we'll produce some output which may be more correct than the previous one. So that is known as iterative refinement. And let us look into a very simple neural network model which is known as perceptron, and it was designed in 1958. So here we have only a single neuron. So we look into the diagram of it. Okay, this is the architecture of it. So here you can see a single neuron, right? You can see a circle. This is a single neuron. Okay, and the we can see some inputs applied to that neurons. So here x1, okay, x2, x3, etc., xn are some inputs which is applied to your neurons, and you can see it is connected. This input is connected to this neuron using this link, and it has some weights associated. Okay, w1 is the weight of this link, w2 is the weight of this link, w3 is the weight of this link, and wn is the weight of this link. Okay, so what is the input that this is applied to this neuron? We are supplying some inputs x1, x2, x3, xn, and some corresponding weights are given. Also, it is taking some bias also. Okay, we have introduced some bias also, so that non-linearity is introduced to the neural network, because in actually in the real world, you know what is linearly separable and non-linearly separable data, right? In linearly separable data, we can differentiate it using a line, right? So we can make a decision boundary easily, and we can separate the classes. But in real world data, most of the data are not linearly separable. Okay, so there should be a mechanism by which we can classify these non-linear data also. So the model will need to learn more complex patterns. So for that, we introduce something known as bias or a non-linearity into the model, so that it resembles or it can learn the complex patterns in the real world data. Okay, so what are the things the perceptron is having? So perceptron means it's a neural network with only one neuron. So this is the one single neuron, and we have two layers. One is the input layer. Okay, input layer consists of these inputs x1, x2, x3 and xn up to xn, and it has an output layer. Output layer will produce the corresponding output. Okay, so two layers are there, input layer and output layer, and we have a neuron. So the input and weight and bias is applied to the neuron, and it will perform some calculation, and finally we get the output. Okay, so the components are inputs. From inputs we have, again we have weight and biases, and then we perform some calculation in the neuron. Okay, that is a net sum. Net sum means what we do is we will multiply x1 into w1. Okay, we'll find the product of these inputs and weights, and then we'll take the sum of it. Okay, that is x1 into w1 plus x2 into w2 plus x3 into w3 plus etc. xn into wn. That is the summation or the net sum input. That is sigma I xi wi indicates x1 w1 plus x2 w2 plus x3 w3 plus etc. Okay, so we perform the summation function here. So you got a net sum over here. Again, we apply some function which is known as activation function. Okay, activation function. On applying this, we'll look into what an activation function is later on. So after applying this activation function, maybe in a perceptron we use a very basic model. That is, we use a threshold value as the activation function. That is, suppose we are giving the threshold value as some 50. If the net sum produces greater than 50, then you will get the output as 1. Okay, example, you can see the activation function described here. So according to the description here, if the output that we got, if the net sum that we got out of this neuron is greater than or equal to some threshold value theta, that is, here in our case, if we are taking theta as 50, suppose the net sum is occurring as some value greater than 50, then you will get the output as 1. And if you get the net sum less than 50, then you will get the output as 0. Okay, so this is how a neuron works, and later on, after getting the output, the neural network will check whether the actual value that it predicted and the predicted value and the actual output it has to get. Okay, that is the actual value and the predicted value will be compared, and if there is a deviation in that, if there is some error in that, then that error will be identified and loss function will be calculated. And in order to minimize that loss, okay, what it does, it will adjust, the neural network will adjust with the help of the optimizers. The neural networks will adjust the weights and bias, okay, of the parameters weight and bias. Okay, initially the weight and bias will be assigned with some random numerical values. So once you compute the loss, then in order to minimize that loss, what the neural network will does, it will adjust the values of bias and weights so that the predicted output is correct. So that is what happens in a neuron. So perceptron is a neural network model with only single neuron, and it has two layers, input layer and output layer. Okay, now you can see an example given here, deciding whether a student gets selected for a college team. Okay, suppose this is your problem, then this actually the input to that neural network, that is x1 x2 etc. It means some date features, input features in your data set. For example, the input features were sports, skill and fitness. So this will be your x1. Okay, this will be your x1, and this fitness will be the second feature, that is x2. These are the inputs to the neural network model, and if you are getting some output like this, z is equal to w1 skill plus w2 fitness plus b. What does this mean? The sports skill feature is assigned with higher value, that is 0.8, and the fitness is assigned with point 3. That means that in the decision making process, your first feature, that is W1, that is skill. Okay, sports skill will contribute more rather than the fitness in selecting a student to a college team. Okay, so weight tells us how strongly each input contributes to the decision, whereas bias means supports your input values as 0 also, then also you can have the output predicted. Okay, or if you want to make some adjustments in your output. For example, suppose the pass mark of a subject is out of 50, the pass mark is some for 30. Okay, and if the teacher finds a question paper to be very difficult, and if she is deciding like, yes, if 25 is scored by the students, then he shall be considered as pass. Okay, if we want to make such type of adjustments in the decision making process, then we can use this bias. Okay, we can make this bias so that some adjustments can be made in the neurons output. Okay, or neurons overall response, that is known as a bias. Now, there are different layers in a neural network. So, the neural network may basically have a single neurons, or it may have multiple neurons also. So, here in this diagram, you can see a neural network model having multiple neurons, right? So, this is your input layer. So, these are your inputs, okay? And these are the some other layers. So, this is your input layer, okay, and this is your output layer. Now you can see that in between the input layer and output layer you have some other thing which is known as hidden layer. So there are some neural networks which may have a third layer also, that is known as a hidden layer. So for every neural network, an input layer and output layer is mandatory, but according to some cases there can be more, there can be an additional layer also which is known as an hidden layer. So hidden layer may contain different set of layers, like this is one set of layer, again this is another set of layer. So as and when the number of hidden layers increases, the capacity of the model to capture complex pattern also increases. Okay, so basically there are three types of layers in neural networks. One is input layer, one is output layer. These two are mandatory, and one we have the hidden layers. So what does the input layer do? Input layer will take the raw input data, okay, or the features of the data sets are given as input to this input layer. So no computations are done there, only it just forwards the data to the next layer. That is, if we are having a hidden layer, it just forwards it to the hidden layer. Okay, and what the hidden layer do? Hidden layer is the layer which is located in between the input layer and output layer. So the main computations are done occurring in the hidden layer. Okay, it will apply the weights and biases to the inputs. It will perform the computations there. It will apply the activation function. Okay, and then it will give us the result. And number of this hidden layer depend, and the size of the neurons within this layers depend upon the complexity of the task. For more complex tasks, you can have many hidden layers, and number of neurons in a hidden layer can also vary. Okay, for example, when you're detecting a face, then first it may identify the edge of the face, then it may determine the shape, then it may, after next hidden layer may determine the features of eyes, next hidden layer will determine nose, and so on. Okay, so according to your task, the number of hidden layers may vary. Output layer means what? The final layer that will produce the prediction. Okay, so you get the output, that is, if you are doing a spam classification, email classification, then you will get the output like whether it is spam, okay, or whether it is not spam and all. Okay, so that you get you can use this neural network for classification purpose as well as for regression purpose. For classification, if you are two classes, you need two neurons as the output. Okay, one neuron per class. Suppose you want to predict whether the image is cat or dog, you need one neuron for cat and one neuron for dog in the output layer. And for regression, one neuron for continuous values, because we are predicting a value, right? So we need only one neuron as a in the output layer. And the neural networks can be classified into two different classes. One is shallow neural network and one is deep neural networks. So look into the shallow neural network. It has three layers: input layer, hidden layer, and output layer. And when it is a shallow neural network, you will have one hidden layer. Okay, you can see one hidden layer. When you have deep neural networks, it has a one input layer and one output layer, and you have more than one hidden layers. So what is the advantage? So here the complexity of the model is less. Here the model is very much complex, but here it cannot capture much complex patterns, but this deep neural network is capable of capturing more complex features, right, or patterns. So when if your task is very much complex means, then you can go for the deep neural network. So the number of hidden layers depends purely on the task. Okay, suppose you are increasing your hidden layers very high, then it may not give you a very good result. So it depends. Okay. Again, this is explanation for shallow and deep neural networks, and you can go through the comparison of it. Next, the working of neural networks. This is what actually we told early. We have the inputs x1, x2, extra. These are the inputs, and these are the weights, and b is the bias. It is given as input to the neuron, and what happens in the neuron? The computations happens. Okay, summation happens, and after that we apply an activation function on top of that, and finally we get an output. Okay. So this can be the summation means w1 x1 plus w2 x2 plus etc. wn xn plus the bias. So in general we can say that w into x plus b. Okay, and g is the activation function that we are giving, and y hat is the predicted output. So what it does is the working of neural networks basically includes three steps. First one is forward propagation. Forward propagation means we give the input, it passes through the network in the forward direction. Okay, that is from the input layer, it may go to the hidden layer and then to the output layer. Okay, no backward propagation is happening, so it moves forward through each layer, and this is known as forward propagation, and it can be represented as a linear transformation, right? Because w1 x1 plus w2 x2 plus etc. Plus b. Okay, and again, second one is the activation function. After performing this linear transformation, then what we do is we apply an activation function. Okay, so the result of the linear transformation is then passed to an activation function. It introduces some linearity into the system. Okay, based upon your task, you can apply different activation function. We'll look into what the activation functions are. Again, that is what is happening in the first forward propagation. Backward propagation means once you have got the predicted the output, you will compare with the actual output, okay, and you will compute the loss, isn't it? So your goal always is the goal of training is always is to minimize the loss. So in order to minimize this, what we apply a method which is known as back propagation. So in back propagation, what we do, we first calculate the loss using the loss functions, okay, and in order to minimize that, we'll take gradient of that loss function, that is derivative, and then we will update the weights. Okay, the optimizer will update the weights. Again, this process will be repeated over time, this will reduce the loss, and so the network will become stable. Okay, so this is iteration. Iteration is done to minimize the loss. Now, what is this activation function? Actually, activation function means it is a mathematical function, okay, used in a neural network model to determine its output after calculating the net sum or the weighted sum of inputs and biases. So, activation function, suppose Z is equal to the weighted sum of inputs and bias, then we apply a function, okay, f. This is known as the activation function. We apply it on the weighted sum, okay, and we get an output from this. So it refers to functions in neural networks to compute the weighted sum of biases. Okay, and it decides like whether a neuron can be fired or not, or whether the value should be 1 or 0. Okay, so it decides whether a neuron should be activated or not. Again, the role of activation function is to derive output from a set of input values that is fed to the node. So why actually we need this input function, I mean activation function. So activation function will transform the weighted sum, okay, into the desired value. Okay, it like if you want to predict a binary classification. Okay, consider we are going to classify your inputs as input mail as like spam or non-spam. Okay, you need two classes, right? So the weighted sum that you're getting out of the neural network should be transformed into either 0 or 1, right? So in order to transform that thing, we use something known as activation function. So it tells us whether we have to fire or activate the neuron or not. It again introduce some non-linearity. Okay, so it will help us to learn more complex patterns, this activation function. So first type of activation function is known as binary step function. Okay, so this activation functions are mainly used in binary classifications. Okay, that is why it is known as binary step function. So it is a threshold function is a threshold based activation. We initially we said no. We suppose the value of the weighted sum is greater than or equal to some threshold. Okay, greater than or equal to 0, then the output will be 1. And if it is less than 0, that is, if it is a negative value, then the threshold will mean then the output predicted will be 0. Okay, suppose you are getting a value like 50, the output will be predicted as 1. Or if then weighted sum is some minus value, it is minus 10, then the value will be 0. For any values that you give, the output will be either 1 or 0. That is why it is known as binary step function. And it cannot be used in conditions where you have multiple classes. It can be used for binary classification problems only. Okay, so the graph you can see that 1 and 0 values given. Again, second type of binary function is known as a sigmoid or logistic activation function. So sigmoid means the graph will be in the shape of the S, and as you know, this zero point 0.5 will be taken as a threshold, and something above that zero point 0.5 will be taken as one class, positive class, and something below, if the value is below that zero point 0.5, it will be considered as a negative class or a zero class, right? So it will express everything between 0 or 1, or it will express the things as a probability. Okay, so this is mainly used for models where we have to predict the probability as an output. Okay, so how probable is it that this mail is spam, or how probable it is that a mail is not spam. Okay, so it will so probability always range between 0 and 1. So therefore the sigmoid function is a right choice when you want to predict something as a probability. Okay, so the equation for computing the sigmoid function is this, and this is the graph that you get out of it. Again, example is given, predicting whether an email is spam or not. Output if it is close to 1, then it is spam. Output if it is close to 0, it is not spam. Again, next activation function is tanh or hyperbolic tangent activation function. It is similar to the sigmoid function, but the only difference is here the value ranges from -1 to 1. Okay. Again, it is also a sigmoidal in shape, so it gives much flexibility than sigmoid function. The output function can range from -1 to 1. It is used in cases where we need to represent the negative values. Also, in sigmoid function, we have the values between 0 and 1. So no negative values can be represented there. But if you want to capture some negative values also, then we can go for this activation model, and this is the formula for computing tanh activation function. Again, example is sentiment analysis, that you are going to classify as positive or negative. Then output near to +1 positive, and output near to -1 indicates it's a negative. Okay. Next is a rectified linear unit or ReLU. Okay, it is one of the most widely used activation function. Mainly, it is used in the hidden layers. Okay, it is defined as f of x equal to max of 0 comma x. Okay, it does not. The main advantage is like if you're having some values. Okay, uh, suppose your x value is some 50, then max of 0 comma 50 means it is 50 itself, right? But if you are giving some negative values like max of 0 comma minus 10, okay, then what will be the output that is coming for negative values? Output will be always 0. Okay, for the positive value it will output the same positive value. So if the input is negative, it will convert into 0 and the neurons does not get activated, doesn't fire. Okay, it doesn't fire. Okay, whereas if your output is greater than 0, then it gets fired. So example, it ignores the negative pixel values and it only pass forward the positive positive values. Okay, so it is mainly used in hidden layers for computations. So we have it has a problem known as dead neuron problem. That is, if the input to a neuron is negative, ReLU always outputs a 0, right? ReLU always outputs a 0, and if input to a neuron is positive, then it always outputs that value. So for every value during training, if the weight updates in such a way that neuron always receives negative inputs, okay, then its value will be always 0. So the neurons will stop learning. If this 0 value is being outputted every time for the negative values, the model doesn't learn anything new. Okay, in that case, we can say it is known as a dead neuron problem. Okay, so it doesn't learn any new features or useful features if the output is always 0. So like if a student in a classroom, okay, stop answering the questions forever means it doesn't learn anything new. So it suffers from a problem which is known as a dead neuron problem, wherein it will not learn if the outputs are continuously 0. So in order to update the weights and biases, this won't help. Okay, but it is we get the results very fast also. That is one of the advantage of ReLU. And next one is softmax function. Softmax function means it is used for multi-class classification problems. That is, if you have more than two classes has to be predicted as output, then you can go for the softmax function. Okay, but it will transform the values between 0 and 1 itself. Okay, so that can be also interpreted as some probabilities, and this is the equation to calculate the softmax. And so this is an example given. Let us compute the activation function value. Suppose this is a neural network that is given. Here you can see that we have four inputs, 0 0.5, 0 0.9, 0 0.2 and 0.3 are the inputs given. Okay. And so this is your input layer and these are the inputs that is given. Again, these are the weights. Okay, and this is the bias that is given. We have to, so here you have an input layer and here you have an output layer, and you have to check what is the output that you get after applying TANH activation function and sigmoid function. So first what we have to do, we have to compute the weighted sum, right? That is 0.5 into 0.2, okay, plus 0.9 into 0.3 plus 0.2 into 0.6 plus 0.3 into minus 0.1, okay, plus this bias will give you the weighted sum, isn't it? So these are the given parameters, your input values, your weights, and bias is given as b is equal to 0.5, and then the neuron calculates as weighted sum. Okay, it is calculated here and we got it as sum 0.72. Now what we do, we will apply the TANH function on this output, and we'll apply the sigmoid function on this output. So first let us apply the TANH function. So TANH function is given by this equation. So substituting that 0.72 of z here in this equation, you will get TANH of 0.72, and then you will get after applying to this equation, you will get the value of y as some 0.617. Okay, and likewise, you have take the formula of sigmoid function, apply z is equal to 0.72 in this equation, and finally you get a value of 0.673. Okay, so that is the values that you get if we apply the tanh and sigmoid functions. So this can be done as a tutorial. Again, loss functions. Loss functions means, again we told loss function means it is how wrong the prediction are. There should be some mechanism in the neural network by which it can understand how wrong the predicted values are, isn't it? So for that we use a function which is known as loss function. So the predicted value and actual values are compared and the loss function is calculated. Okay, so there are different types of loss functions. We have classification and regression problems. So for regression problems, we have two types of, there are different, but we are going to look only into two types of losses in regression and two types of losses in classification. So for regression, we use regression is done on to predict continuous values, right? So we use two numerical kind of losses, that is mean squared error and mean absolute error. So this is the formula to compute the mean square errors. Since it's a regression problem, we use mean square error and mean absolute error to calculate the loss functions. So this is the equation. So you can just by heart the equation. It is the measured as the average of squared differences between, okay, differences between predictions and actual observations, and this is a square, and we perform the summation of it. Again, these are some of the variations of the mean square error, and we use this RMSE also. Again, example for an MSE is given here. Suppose you are given your predicted value is this and your actual value is this. Then what you have to do, you have to initially compute the error. How error is computed? Predicted minus actual. 48 minus 60, you get minus 12. Then you have to find the square of it. Likewise, for each inputs, you have to find the squared error, take the summation of it and divide it by 3 because you have 3 samples, and you will get a value. Okay, you can see that 52.3 is a huge loss value, right? So your predicted and your actual output has a very much difference. So your model has to retrain this, right? It has to adjust the weights and biases and again perform this and see whether the error is decreasing. Again, this is the mean absolute error. Here we take the absolute values of predicted and actual. Okay. Again, the classification laws, we use two techniques, binary cross entropy and categorical cross entropy. So binary cross entropy will be used for what? To predict, if you are binary classification you are performing means we can use this, and if you are doing a multi-class classification means then you can use categorical. Okay. So binary cross entropy is same as the equation for decision tree, similar to the decision tree equation, loss function or entropy that we calculate in the decision tree algorithm. No, it is similar to that. Okay, it is using binary classification. Model takes in an input and has to classify it into one of the two preset categories. Again, categorical means it is used in when we have more than two classes. Okay, so it is computed using this. We utilize cross entropy. So it follows a similar process of binary cross entropy. So you have to by heart